Hello everybody, this is Mrs. Ewald and welcome to your first podcast of Honors Chemistry. What we're going to do is quickly talk about measurement and how to measure and understanding the uncertainty that there is with measurement. So first of all, let's go ahead and look at let me get my pen. Let's look at this ruler, and we are trying to measure the diameter of this penny. So we always want to estimate one digit past the markings on your instrument, as it says. Understand too that every piece of instrument, rulers, scales, anything that you use really in the lab is going to have some level of uncertainty with it. So there is always going to be some level plus or minus. And so we write that as plus or minus, showing the degree or the level of uncertainty. And so if we want to measure, just using an example, this penny, and we want to measure the diameter, well, we right away can tell from the large numbers, the large markings there, pretty easily what the first number would be. And so looking here, we see 3 and 4. In between, it would be 3.5. So we're measuring from here all the way to here. And we know that the first digit, or what we call the certain number, certain digit, will be first. And so reading this, this would be 3 point something. And so this is definitely certain. Then we would look, well, it's 3, and that's 3.5. So this would be 3.1, 2, 3, 4, 5, 6, and 7. And it's past 7. So it would be 3.7. This would also be certain because everybody reading this knows that it is reaching this point, and we would all agree for sure that it's going to be greater than 3.7. Then what we would do is zoom in on this measurement and look at these two hash marks. Now, if we could zoom in and see a picture of this, it would look like this. And we would be able to divide this up into 10 separate pieces. So 3, 4, 5, 6, 7, 8, 9, and then the next hash mark. And so looking at this, if we were to zoom in on it, it's not quite over in the middle, so that would be 1, 2, 3, 4, 5. It has not really quite reached this, and so it would be plus or minus in here. And so me reading this, I would say, it's not quite there, but I'm going to say that it's about halfway, close to halfway. So I'm going to say that this is 3.74. This digit here is what I rounded. And we're going to call this the uncertain digit, or number, as your book says. Please refer to page 23 in your book to get further information on certain and uncertain digits or numbers, certain and uncertain numbers. Okay, so these here would be my certain, this here would be my rounded, my uncertain. And so I am only as precise as my instrument, and so I can only go as far as this. I could not go another decimal over and say that it's 3.740. Why? Because I cannot see that from my measuring tool. I'm limited by that. And so measurement will always have some degree of uncertainty, and measuring tools are going to have that certain level. You can only be as precise as your instrument that you're using. This idea will then eventually lead to our next podcast getting into significant figures, because it's because of our measuring tool and the preciseness of our measurement that's going to limit our answers when we get into calculating. Again, we can only be as precise as our least precise instrument. So let's go ahead and look at this here. This here is showing you a graduated cylinder, and you're seeing the meniscus of the graduated cylinder. And so you're always going to read it from the bottom of your meniscus. So if we wanted to read this, how much liquid do we have? Now we're talking about a volume. We're going to be talking about mils. And by the way, going back, this needs to be centimeter. Always have a unit. Bad Mrs. Ewald. Always have a unit. All right. So looking at this, we want to read this. Now you're looking at 7 and 8. Right in the middle here, this larger hash mark, that would be 7 mils. And so in between, dividing this up, this would be then like 6.2, 6.4, 6.6, 6.8, and then 7. And now this meniscus, from this picture here, you always want to measure from the bottom of your meniscus as best as you can. So this will give you the correct volume. If you read too high, you're going to have too high of a volume. If you read too low, you would have too low of a volume. And you always want to read at eye level in order to appropriately read the volume because of the appearance of which you have in the graduated cylinder. However, some graduated cylinders actually, based on the material that they used, you might just see a straight line, which is very, very easy then. Let me finish my cylinder there in order to read it. And so looking at this, you know, again, we're only able to read according to the precision as far as we can, according to our graduated cylinder. So this one, you would say that this is about 6.246. And it probably goes a little bit above. So with this, because we can then estimate, so our certain digit we could say is 6 and 6. These are certain. And we could go one more out because in between these, we could then say about 6.6, I would say 1. But notice, you all might be thinking a different number. However, because this is our uncertain or our rounded, you can then give a level of uncertainty, and we can write this then as saying, we could say 6.61 centimeter, or I'm sorry, mil, plus or minus 0.01 mil. So about plus or minus 0.01. That gives you a level of difference. And so some of you might say 6.61. Others of you might say 6.60. Okay? Or 6.62. So it gives you the different levels accounting for that. All right, as far as with scales, there is an exception in the fact that the amount that they actually give you on the picture, you don't want to estimate when using an electronic balance because it is already measuring, it's rounding that last digit for you. So you don't have to estimate it. It already does it for you. But understand, though, that that's the estimated, the rounded digit, which is why whenever you're measuring anything on the scale, you always kind of see this one, you know, flickering a little bit, fluttering a little bit until it stays on 1. And whichever that has the star on it, then when it stays on it, that would be your best measurement because it stayed on there the longest or it stabilized there the longest. All right, so as far as your turn goes, before we go and look at this, let's just recap really quickly. We've looked at certain and uncertain digits, and at this point we've talked about uncertainty. Understand that with uncertainty, what we are talking about, understand uncertainty. Understand what we're talking about is the fact that if you're uncertain about something, you could go one way or the other. So you could either go up or down, and so our measurement could be a little bit more than we thought or a little bit less than we thought. And so it's one way or another. That's what it means to be uncertain. So this means we could be plus or minus a little bit more, a little bit less, and it could be plus or minus 0.1, plus or minus 0.01. It depends on the precision of your measurement or whatever it is that you're using, your tool, your equipment. So for example, you might have somebody look at this, for example, and we may do something like this in class where we actually use rulers to measure something. And so here, if we were to measure an ID, and you're looking at the ruler, you're going to see right away, here's your big bullet point right here. So 2, that's where we're going to start. It's past 2. Look at your 2 dividers here, 2 and 3. Okay. It's going to be a little bit less than 2.5 centimeters. Okay. But we know for sure our certain digit here would be 2. Our next certain digit, we could definitely say it goes past this hash mark. So that would be 1, 2, 3, 4. These two are certain digits, and then you would have to round for the last one. So it's in between these two. These are definite, and so we have to look at inside where it would be. And I could say that's 2.45 centimeters. But somebody else out there might say, well, wait a minute, I think it looks like 2.44. Or somebody else might say, well, I think it kind of looks like 2.46. You all might be correct because there is that level or degree of uncertainty. So you could say it's plus or minus then 0.01 centimeters. Again, taking into account the uncertainty. And so no measurement is absolutely exact because of understanding this level of uncertainty. So when we get into calculating, we want to think about that, and we're able to adjust for things by using significant figures when we calculate. So I think that about covers everything that I wanted to cover for this podcast. You're going to be using this to help you then when starting with Ms. Heaton's podcast on significant figures and understanding why we use significant figures. Again, please refer to page 23 in your book to look more at uncertainty with certain and uncertain, rounded digits, and I think that about covers it. So this is Mrs. Ewald signing out, and I will see you again in the next podcast. Bye-bye.